Have you ever just stopped and wondered how the internet actually works? I mean, it feels like magic, right? But it's not. Today, we're going to pull back the curtain and meet the invisible services, this kind of background orchestra that makes your entire online life happen. Okay, let's get into it. Think about it. You do this dozens, maybe hundreds of times a day. You type in a website, you hit enter, and bam, the site just appears. But what is going on in that tiny little split second between your finger hitting the key and that page loading? It's not magic, but honestly, what's happening behind the scenes is just as amazing.
That one single click kicks off this incredible, high-speed journey across the entire globe. And guiding every single step of that trip is a whole team of essential background services. You can think of them as the navigators, the translators, and even the traffic cops of the internet, all working together in perfect harmony to make sure your request finds its destination and that all that content you want gets right back to you.
So where does a journey like this even start? Well, it begins the very second you connect your laptop or your phone to a network. Before your device can send or receive even a single byte of data, it needs an identity. It needs a kind of digital passport to prove it belongs there.
And this is where our first helper, DHCP, steps onto the stage. DHCP, which stands for Dynamic Host Configuration Protocol, is basically the network's friendly front desk clerk. The moment your device connects, DHCP greets it and says, "Hey, welcome. Here's your own unique IP address and all the other info you're going to need to get online." And the best part? It's all completely automatic.
And why is this so important? Well, without DHCP, you'd have to manually type in a unique IP address for every single device you connect. Can you imagine trying to do that in an office with 1,000 computers? It would be an absolute nightmare of typos, address conflicts, and just so much wasted time. DHCP is what makes networking plug and play, and it's the real reason you can walk into any coffee shop, connect to the Wi-Fi, and get online in seconds.
And this all happens in a flash, through a super quick, four-step conversation called the DORA process. First, your device basically shouts out a discovery message, asking if there's a server out there. A server hears it and makes an offer. Your device then sends a request saying, "Yep, I'll take it." And finally, the server sends back an acknowledgement to make it official. This whole negotiation is over and done in the blink of an eye.
All right, so our device has its digital passport and it's ready to go. You type in a website you want to visit. So what's the next challenge? Well, it's finding that website's specific numerical address on the huge, sprawling map of the internet.
And here's the basic problem we need to solve. We humans remember names, right? Like Google.com. That's easy. Computers, on the other hand, only understand numbers, like this long string of digits here. We're essentially speaking two different languages. So to connect, we need a translator.
And that translator is our second unseen helper, DNS, the Domain Name System. And honestly, this is the perfect analogy. You don't memorize all your friends' phone numbers, right? You just look up their name in your contacts. Well, DNS does the exact same thing for the internet. You give it a name, like youtube.com, and it looks up the matching number, which then allows your browser to connect. Simple as that. Okay, so we have our own address, and thanks to DNS, we now know the address of where we want to go. Now it's time to leave the safety of our local network, our home or our office, and merge onto the public highway of the internet. And this is where a really, really important service called NAT, or Network Address Translation, comes in. NAT is the gatekeeper for your entire network. It's totally brilliant because, for one, it helps conserve the world's limited supply of public IP addresses. But maybe even more importantly, it acts like a firewall, hiding all of your private, internal devices from the outside world. It gives you a huge security boost.
Just think about it. Inside your house, you might have 10, 20, who knows how many devices connected. Your laptop, your phone, your smart TV, your game console, they each have their own private address, kind of like apartment numbers inside a big building. These addresses only work for internal communication.
But to the entire rest of the internet, all of those different devices look like they're communicating from one single public address. This is like the main street address for the entire apartment building. NAT is the magic that translates all those private internal apartment numbers into that one public external address.
So how does the right data get back to the right device? I mean, if you're streaming a movie while somebody else is on a video call, how does the router know what goes where? Well, that's the job of PAT, or Port Address Translation. It's kind of like adding a unique apartment number to each piece of outgoing mail. When the replies come back to the building's main address, Pat just checks that apartment number and makes sure the package gets forwarded to the correct device. It's really clever.
So,
We've successfully joined the network. We found our destination, and we've merged onto the internet highway. But our journey isn't done yet. Now we have to meet the essential support crew. These are the services working quietly in the background, 24/7, just to keep this digital highway stable, secure, and running as smoothly as possible. And this crew has a specialist for every single job. We've got NTP, the official timekeeper, making sure all of the clocks are in sync. SNMP is the health monitor, constantly checking the vital signs of all the equipment. Syslog is the meticulous record keeper, logging every important event. QoS is the traffic cop, managing all the congestion. And then you have FTP and TFTP, the heavy lifting file movers.
First up, let's talk about NTP, the Network Time Protocol. Why is having synchronized time so important? Well, just imagine trying to piece together a sequence of events from security logs where every device has a different time. It would be totally impossible. On a network, having everyone agree on the time is absolutely critical for accurate security logs, for validating digital certificates, and for figuring out what happened and in what order when things go wrong.
Next up is SNMP, the Simple Network Management Protocol. This is our health monitor. It's what lets network engineers check the vital signs of every single router and switch on the network. The manager is their dashboard. An agent is a little piece of software on the device being monitored. And the MIB, or Management Information Base, is just a database of all the vital signs that the agent can report on, like CPU usage or how much traffic is flowing.
Now, here's what's really important to understand. It's evolution. The early versions of SNMP were actually a huge risk because they sent all this sensitive management data in plain text that anyone could read. This is exactly why any modern network absolutely insists on using SNMP version 3, which adds that crucial layer of encryption to keep all that network control and monitoring data locked down and secure. Then we have Syslog, the network's official record keeper. Every time something significant happens on a device, a user logs in, a connection fails, an error pops up, it sends a detailed message to a central Syslog server. These messages are all categorized by severity, from a level 7 debug message all the way up to a level 0 emergency, which basically means the system is unusable. This system lets engineers instantly filter through all the noise and zero in on the really critical problems.
Now for the Traffic Cop QoS, or Quality of Service. Your internet connection is a shared road, right? Without QoS, a massive file download could just clog up all the lanes, making your important video call stutter and freeze. What QoS does is establish priority lanes. It makes sure that real-time, delay-sensitive traffic like your voice call always gets a clear path, while less urgent things like that big download can just wait in the slow lane.
And finally, let's meet the file movers. You've got FTP, the File Transfer Protocol, which is the reliable, feature-packed choice for general file sharing. It's built on a solid connection and supports security features. Then you have TFTP, its trivial little brother. It's a faster, way simpler protocol that's perfect for quick admin tasks inside a secure network, like backing up a router's configuration, where you just need raw speed above all else.
So, we've met the entire team now. The ones that get you connected and the ones that keep you connected. Now let's put it all together and see how they perform in a complete, real-world digital journey from start to finish.
All right, let's do a quick lightning round recap of our key players. DHCP gives you that automatic IP. DNS handles name resolution. NAT and PAT provide secure internet access. Then the support crew kicks in. NTP for time sync, SNMP for monitoring, Syslog for logging, QoS for traffic priority, and FTP or TFTP for moving files. Got it? Good.
Now, let's watch it all happen in real time. You open your laptop. Instantly, DHCP assigns it an IP address. You type in a website, and DNS finds its numerical IP. Your router uses NAT to securely send your request out onto the internet. As you join a video call, a switch using QoS makes sure that traffic stays smooth. And all the while, Syslog is logging these connections for security, and SNMP is monitoring the router's health to prevent any problems. It all just happens together, a seamless, invisible symphony.
Every single click, every video you stream, every post you make is really a complex symphony being performed by this invisible orchestra of protocols. They are the true, unsung heroes of our connected world. And that kind of brings us to a final thought. What other invisible tech is hiding out there in plain sight, powering your daily life? Thanks for watching.